This tutorial looks at transition elements, at the colours of some of their compounds and at the decomposition of some of their metal carbonates. All of these pictures here are objects which are made from transition elements. We'll look at the position of the transition elements in the periodic table and understand that these are elements which are generally used for constructing things. This diagram shows the position of the transition elements in the periodic table, and you can see here there are some fairly well-known metals. We have, for example, zinc, we have copper, we have nickel and cobalt, iron, manganese, chromium, vanadium, which is used in some forms of steel, titanium. We also have some of the precious metals here, silver, gold and platinum, and other metals which are used as catalysts like iridium and rhodium. We need to know that the compounds of transition metals are often coloured, and recall the colours of these. Actually very similar to what we learnt in a previous tutorial about the colours of the precipitates which are made when certain solutions of metals are reacted with sodium hydroxide, and also that the elements and their compounds are often used as catalysts. Here's three transition element compounds. We have copper sulfate here, a fairly typical copper 2 compound which is blue. We have iron 2 sulfate here, a fairly common colour for iron 2 is this green colour. And we have iron 3 sulfate here, which is an orangey brown colour typical of Fe3+ compounds. So, transition metal compounds are often coloured, and you need to know the colours of three of these. That copper 2 compounds or copper compounds are blue, that iron 2 compounds, those containing Fe2+ ions, are light green, and that iron 3 compounds, those containing Fe3+ ions, are orangey brown. It's also worth noting that transition metals are what you'd call typical metals. They have typical metal properties, such as that they have high melting points, they're hard, they're strong, they're good conductors of electricity and good conductors of heat, they're shiny and they're dense. Also, you need to know that metals or their compounds are often used as catalysts. For example, in Module C2, when you learnt about the production of ammonia from nitrogen and hydrogen, you learnt that the catalyst in that case was iron. Iron here is a transition metal. And you also need to know that nickel, which is found here, is used in the manufacture of margarine. Margarine is made by reacting vegetable oils, particularly unsaturated vegetable oils, with hydrogen gas in the presence of a nickel catalyst. Here's a past paper question on this topic. This question is about the periodic table and transition elements. Look at the diagram. It shows the position of some elements in the periodic table. Write down the symbols for two elements that are in the same group of the periodic table. Well, a group is a vertical collection like this. So the only two which are in the same group are Na and K. Write down the symbols for two elements which are in the same period. Well, a period is a horizontal line, and the only two which are in the same period here are these two, which are K and Ni. And write down the symbol of a transition element. Well, transition elements are in this group in the centre of the table. So an example of those would be Ni. Compounds of transition elements are often coloured. Iron 2 compounds are usually green. Syllabus says pale green. Look at the list. It gives the colours of some transition metal compounds. What colour are most copper compounds? Well, copper compounds are generally blue. And iron 3 compounds, out of that choice, I would say orange. Usually we'd say orange or orangey brown. The next part of this tutorial is to learn about thermal decomposition of transition metal carbonates. Now, thermal decomposition is a description of a chemical reaction which uses heat, that's the thermal bit, to break down, that's the decomposition bit, a compound into two or more other substances. In order to show decomposition of a transition element carbonate, we tend to heat the carbonate in a boiling tube, as shown here, with a delivery tube going into a test tube of lime water. In this reaction, thermal decomposition takes place. The metal carbonate breaks down into, in fact, two parts. One part is the metal oxide and the other part is the gas carbon dioxide, which travels along the delivery tube and turns the lime water milky. You need to know that the test for carbon dioxide is that it turns lime water milky. You also need to be able to construct word equations for these thermal decomposition reactions. The word equations for each of these are similar and they follow the same pattern. Copper 2 carbonate breaks down to make copper 2 oxide and carbon dioxide. The iron 2 carbonate would break down to make iron 2 oxide and carbon dioxide. Similarly, the manganese carbonate breaks down to make manganese oxide and carbon dioxide. Apologies for the writing. And zinc carbonate breaks down to make zinc oxide and carbon dioxide. Here's a past paper question. Brahim investigates what happens when he heats some solids. Look at the apparatus he uses and look at the results table. It says look at the results table. Okay, I'm looking. 2 solids make carbon dioxide when heated. Which 2? Well, carbon dioxide is tested using lime water and carbon dioxide makes lime water go milky. And there's only 2 of them where the lime water has gone milky. That's by heating the carbonates. So the 2 answers are copper carbonate and zinc carbonate. This is the decomposition of transition element carbonates to give the oxide and carbon dioxide. And there's our answer, both required for 1 mark.